Imagine if every 2 years your bank balance doubled. Sounds amazing, right? Well, this is somewhat similar to what Moore's law is all about, but in the world of computing. It all started with a prediction made by Gordon Moore, co-founder of Intel, back in 1965. Moore noticed a trend, a pattern. He saw that the number of transistors, those tiny switches that carry out all the heavy lifting inside a microchip, was doubling roughly every 2 years. And while they were doubling, the cost of computers was being sliced in half. It's like getting twice the bang for your buck, but in the realm of technology. This prediction, or law, has since become the golden rule for the tech industry. It has fueled the explosive advancement of digital technology, pushing boundaries and redefining what's possible. So in essence, Moore's law is the reason why our devices become more powerful and cheaper at the same time. You might be wondering, is this just a theory, or does it really happen? Well, evidence supports Moore's law. Let's take a look at the past few decades. In the 1960s, the most advanced processors housed a few thousand transistors. Fast forward to the dawn of the 21st century, and we find billions of transistors packed into processors no larger than a postage stamp. This exponential growth in computing power while maintaining compact form factors is a testament to Moore's law in action. But it's not just about the number of transistors. The size of these transistors has been shrinking too, from tens of microns in the early days of computing to just a few nanometers today. This miniaturization has allowed for more efficient and powerful processors, proving Moore's assertion that we can double the number of transistors in a dense integrated circuit approximately every 2 years. And then there's the cost aspect. As technology has advanced, the cost of computing has decreased dramatically. Back in the early days, computers were luxuries only the biggest corporations could afford. Today, powerful computing devices are accessible to almost everyone, further reinforcing the validity of Moore's law. The influence of Moore's law extends beyond just computer manufacturing. It has fueled advancements in various fields, opening up new frontiers in technology. Artificial intelligence, for instance, has benefited greatly from the increase in processing power, enabling more complex algorithms and sophisticated machine learning models. Virtual reality, too, has seen leaps in development, thanks to the ever-increasing power of our computing devices. Even the emerging field of quantum computing, which stands to revolutionize our understanding of computation, is being driven by the same principles that underpin Moore's law: the pursuit of faster, more efficient processing capabilities. From the computer in your pocket to the most powerful supercomputers, Moore's law has been a driving force behind their evolution. Now the big question is, will Moore's law continue to hold true, or is it coming to an end? Moore's law, the principle that the number of transistors on a chip doubles approximately every 2 years, has been a guiding light for the tech industry for more than half a century. However, it's facing significant challenges that make its future uncertain. Firstly, there are physical limitations. As we continue to shrink transistors to microscopic sizes, we're approaching the limits of what's physically possible. We're dealing with features that are just a few atoms wide, and at this scale, the laws of quantum physics start to interfere with transistor function. It's like trying to build a sandcastle with grains of sand that refuse to stay put. Secondly, there are economic factors at play. The cost of developing and manufacturing these increasingly complex chips is soaring. In fact, some industry insiders have suggested that economic constraints, rather than technological ones, might be the real barrier to Moore's law. Lastly, technological hurdles also pose a challenge. As transistors become smaller, they generate more heat. Dealing with this excess heat is a significant engineering problem that needs to be solved if Moore's law is to continue. However, it's not all doom and gloom. The end of Moore's law could pave the way for new and exciting technologies. Quantum computing, for example, promises to deliver computational power far beyond what's possible with today's computers. Similarly, nanotechnology could allow us to build devices at the atomic level, potentially bypassing the limitations of traditional silicon-based technology. So, While the future of Moore's Law may be uncertain, it's clear that the spirit of Moore's Law, the relentless drive towards faster, smaller, and cheaper technology, is alive and well. Whether Moore's Law will eventually grind to a halt or not, one thing is certain. The quest for faster, smaller, and cheaper technology will continue to drive innovation and change our world in ways we can't even imagine yet.